Okay, you have now entered Unit 4, Chapter 2, Lesson 1. Unit 4, Chapter 2 will focus on fractions. And Lesson 1 will look at how to understand and compare fractions, equivalent fractions, as far as being able to raise fractions to higher terms, or even simplify fractions and understand that they still represent the same part of a whole. Converting mixed numbers to improper fractions will be the last lesson, as well as being able to convert improper to mixed numbers. So let's start. Take a look at the first picture of the pizza here. This pizza has been cut into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8 pieces. 8 represents the whole, which is why 8 is in the denominator. Notice how one piece has been taken out or eaten. That one piece is a part of the whole, and that is the numerator. So 1 represents what you have, and 8 represents the whole. Therefore, a fraction is a part of a whole. So let's take a look at some examples. The first one, let's first find out how many represent our whole. So I'm going to start by numbering the pieces. This is 1 piece, 2, 3, 4, 5, 6, 7. So 7 is our whole, therefore 7 goes in the denominator. How many pieces are shaded? Well, as you can see, I've numbered them. 1, 2 pieces are shaded. So 2 pieces out of 7 whole pieces are shaded. So the fraction is 2 out of 7. I would like for you to try the second and third example. Let's move down. So next we have equivalent fractions. Equivalent fractions are fractions that represent the same amount of a whole. Equivalent fractions are created by multiplying or dividing both numerator and denominator by the same number. So in our chart here, we have the fraction 1/2. If I multiply 1/2 by 2, I will create an equivalent fraction. Another term for this is taking the base fraction and raising it to higher terms. You will need to do this sometimes when you're trying to create common denominators, either to compare fractions or to add or subtract fractions. So it's important that you understand equivalent fractions. So let's try 1/2, and we're going to raise it to 2, or multiply both the numerator and denominator by 2. So this would mean I would do 1 times 2, which is 2, and 2 times 2, which is 4. So notice how the new fraction is 2 out of 4. 2 out of 4, if I draw this picture and I cut it into 4 equal parts as best I can, 1, 2, 3, 4, and I shade 2 of the parts, 2 out of 4 still represents half of the whole. Same thing if I multiply by 3. 1 times 3 would be 3. 2 times 3 would be 6. 3 is half of 6. So it still represents 1/2. If I multiply by 4, I would get 4. And 4 times 2 is 8. 4 is half of 8. So even though the numbers in the fraction have changed, they still represent the same portion of the whole, which is 1/2. Let's scroll down. I want you to complete the chart for 3/4 and 2/3. After you complete that, then let's scroll down and let's look at comparing fractions. There's a couple different ways we can compare fractions. The first way is finding the common denominator. The second way is by cross multiplying. And the third way is by converting to decimals. Let's first take a look at finding a common denominator. And when we compare fractions, we use symbols of less than, less than, greater than, or equal to. So we have the example 2/3 and 3/4. So before I do this one, I just want to show you, if we had like, let's say 1/6 and 4/6, when we have a common denominator, it's easy to tell which one is greater than the other. The issue comes in when the denominator is not the same. So when the denominator is not the same, we can get a common denominator. We can get a common denominator by first listing the multiples of both denominators. So that's what we have here. 3, I've listed the multiples of 3, 3, 6, 9, 12. And for 4, I have 4, because 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. I have stopped because I have reached a common multiple. This is also known as the least common multiple, which gives us our common denominator. A second way to get that common denominator, if your numbers are small, sometimes it's easy just to multiply the two denominators together. And as you can see, I get the same common denominator. Once you have your common denominator, we simply do what we did with equivalent fractions. We're going to create equivalent fractions, and we're going to multiply each fraction by a number that will create a denominator of 12 in both fractions. So let's take a look here. The first fraction, 2/3. Well, in order to make the denominator 3 turn into a 12, I have to multiply by 4. And in order to keep the fraction equivalent, I have whatever I multiply the denominator by, I have to multiply that to the numerator as well. So then I reach the equivalent fraction of 8/12. 8/12 and 2/3 are equivalent fractions. So we have the new 8/12 is the new fraction for 2/3. Now let's look at 3/4. In order for 4 to become 12, I had to multiply by 3. Therefore, I have to multiply my numerator by that same value. And I get the equivalent fraction 9/12. So 9/12 is the new fraction for 3/4. Now I can clearly see which fraction is greater than the other. 9/12 is greater than 8/12. Therefore, 3/4 is greater than 2/3. Or 2/3 is less than 3/4. The second way is using cross products. Now here's the thing with cross products. You have to start with the bottom denominator and you multiply to its diagonal. The product you would list above the numerator that you point to, that you multiply to. So 3 times 3, and this 3 is in the numerator, so 9 goes above it. And here's the second denominator, 4 to the numerator of 2, that's 8, so 8 is the new numerator that goes above the 2. Now I can clearly see that 8 is less than 9, or 2/3 is less than 3/4, which also shows me 3/4 is greater than 2/3. The third way is to convert them to decimals, which is another very simple way. Remember that fractions, any fraction represents a division problem. So yes, 1/2, 1/2, you have to remember that that fraction bar is also a division bar. Therefore, this means 1 divided by 2. So I could clearly change this into a division problem. And if you recall lone division, 2 cannot go into 1, so that would be 0. And I would have to create a decimal here and bring down a 0. Now 2 will go into 10 5 times. So now I write 10, because 5 times 2 is 10, subtract, and I have no remainder. So 0.5 is the decimal form of 1/2. So when I convert to decimals, notice how it's through division. And now I can clearly see that 2/3, which is 2 divided by 3, is 0.67. However, the decimal value for 3/4, or 3 divided by 4, is 0.75. And 0.75 is definitely more than 0.67. let's look at the next examples here, and we're going to try. I'll do the first one and you'll complete 2, 3, and 4. So I'll do it by finding a common denominator, because that is a skill that you will need throughout this unit on fractions when it comes to adding and subtracting fractions, more so than converting to decimals or cross multiplication. So we have 8 and 10. So I'm going to list the multiples of 8 and 10. So for 8, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 gives me 24. 8 times 4 is 32. And 8 times 5 is 40. For 10, 10 times 1 is 10. 10 times 2 is 20. Then we have 30. Then we have 40. Notice we have a common multiple. The least common multiple is 40. So now I need to change both fractions to a denominator of 40. So we're going to create an equivalent fraction out of both fractions that has a denominator of 40. 10 times 4 is 40. So therefore 9 times 4, I have to do 9 times 4, which gives me 36. Now 9/10 has an equivalent fraction of 36 over 40. So we renamed it. Now let's look at the other side. I have to multiply by 5 to get 40. So therefore I have to do it to the numerator, times 5. 5 times 4 is 20. So this is 20 over 40. I can clearly see that 36 out of 40 is more than 20 out of 40. So therefore 4/8 is smaller than 9/10, less than 9/10. I want you to try 2, 3, and 4, and then check in your lesson with your teacher. Let's move down. So now what happens when we need to convert between mixed numbers and improper fractions? So remember that idea that sometimes a fraction is a part of a whole. However, sometimes when we have improper fractions, we have a mixture of wholes and a part together. So for example, 9 over 4. In order to take an improper fraction is when the top is heavier than the bottom. So 9 is greater than 4, and this creates an improper fraction. When this happens, we have to divide. So we take the 9 and divide it by 4. So 4 into 9. 4 goes into 9 2 times. 4 times 2 is 8, so we subtract 8, and we're left with a remainder of 1. You take that remainder and you put it over the denominator of 4. So now we have 2 and 1/4. Now let's try another problem. We have 7 over 2. This is improper because 7 is bigger than 2. So therefore we have some wholes within this fraction. So let's look here. I would have to do 2 into 7. 2 will go into 7 3 times. This means I have at least 3 whole pieces. So I'm going to finish this and then I'll represent it visually as well. So 3 times 2 is 6. So subtract. 7 minus 6 is 1. This is my remainder. So my remainder of 1 will go over my denominator of 2. 3 1/2. So I have 3 whole pieces and half of another piece. And I just want to visually draw this out for you. So let's see here. That means I have 2 over 2. That's 1 whole. Another 2 over 2. That's another whole. And another 2 over 2. Notice if I add these together, 2, 4, 6, this gives me 6 pieces, but I have 7. So therefore now I have 1 out of another whole. So 1, 1, 1, 1, 2, 3. You can see this is 3 1/2. So several different ways that you can get your solution there, both through long division as well as visually. Now let's scroll down and let's look at how to take a mixed number and convert it into an improper fraction. So the steps here, if you recall, we take the denominator, multiply it to the whole number. So 4 times 2, which is 8, and then we add